Hello, chemistry people. I'm just going to go over this problem that we started discussing in class today about limiting reactant. So our task here is to figure out which of these reactants, iron or oxygen, is going to run out first. And to find that out, we're going to follow the steps in blue on the right there. That is to find limiting reactant. And we're going to do that by converting both of them to moles, dividing by the coefficients, and the lowest number is going to be our limiting reactant. Okay, and then once we figured out what the limiting reactant is, that's going to be our starting point to determine how much of our product we're going to make. And then we'll just it'll become a problem like we did in class at the beginning of the class, just converting either mass or volume of one of the reactants into the mass of our iron 3 oxide. Okay, so here we go with, first of all, finding limiting reactant, following those three steps there. Here we go. So first of all, dividing 95 grams of iron by its molecular mass, 55.8, which is 1.7 moles, and then we divide by the coefficient, and that gives you your answer. Sorry, it gives you your answer, which is 0.4, let's say 43. Okay, and we kind of ignore the units there because really this is like 4 moles from this here. This means 4 moles. So the units kind of cancel out. This just gives us a number to see which one's going to run out first. We're not going to use the 0.43 in any calculations. It's just for us figuring out what is the limiting reactant. Could do the same thing for oxygen over here on the right hand side of this calculation here. And we see that the number we get there, 1.41, is a lot bigger than the 0.43, meaning that iron is my limiting reactant. Okay, so what that basically means is I can ignore that, the mass or the volume, sorry, of oxygen because I have too much of it. It is the mass of iron that determines how much product I'm going to make, so that's where I'm going to start. And like I was saying before, I caution against using this number for any calculations. It's not that you can't, it just gets a little confusing. So what I suggest you do until you're like a super duper pro and you know all that's going on and everything is just start back to the beginning. It's a very good place to start. And that will kind of guide you the rest of the way. But if you think you can make it work, starting with the 0.43, that's fine. I'll show you how that comes out in the wash in just a second. But let's go back to the beginning and start with the mass of iron. So the first thing we're going to do then is we're going to convert our mass of iron to moles of iron, and then we're going to go from mass to moles of iron, and then we're going to use a mole ratio to go to moles of Fe2O3, and then finally we're going to go to the mass of Fe2O3 using the atomic mass or the molecular mass of Fe2O3. Okay, so that's our path. Here we go. So now that we have moles, after dividing by 55.8 grams per mole, we're going to apply the mole ratio, which is, I want moles of Fe2O3, so that goes on top, Fe2O3, and the 2 comes from right there, and then over here I'm going to write on the bottom side there 4 Fe. So it's a 2 to 4 ratio, or 1 to 2 you could use as well, same thing. And then the last thing you're going to do is you're going to multiply by 159.6 grams per mole, which is the molecular mass of Fe2O3. And by the way, it's also the molecular mass for copper sulfate. Isn't that weird? Anyways, coincidence. So that is going to be the calculation that you're going to do. What I want to quickly show you is where the 0.43 sort of is hiding in this. If you do 95 divided by 55.8 divided by 4, that's the 0.43 that we just finished doing to figure out the limiting reactant. So if you got to that point and then you could see, oh, I just need to multiply by this and by that, and I'm the rest of the way there, then yeah, you could start at the 0.43, but you might be thinking to yourself, oh my gosh, that's ridiculous. Why would I ever do that? I would tend to agree. But you know what? You be the judge. So all we're going to do then for the rest of us, the normal people, we're going to do 95 divided by 55.8 times 2 divided by 4 times 159.6, which is going to spit out our answer, 136 grams of Fe2O3 to 3 sig figs. Everything is there. All right. So that's that problem, and we will get a chance to do more of these in class tomorrow. So see you then.